In this video lecture, we're going to discuss the calculation of the total work done on some object on which they're acting a number of different forces. In our case, there will be 4 different forces acting on our object. Our object is a 10-kilogram block resting on a tabletop. It moves a distance of 6 meters over some unspecified period of time we don't care about. The 4 forces that are acting on this object are first a pulling force of 60 newtons that's acting along a line that is 25 degrees above the horizontal. There is a contact force that exists at the interface of the block and the table that's perpendicular to the table, making an angle of 90 degrees with respect to the positive x direction. Then there's the kinetic friction acting, symbolized as F. We don't bother to put a subscript K to remind us that this is kinetic friction. And that friction has a magnitude equal to the coefficient of friction, mu, which is 0.10, times the contact force. And then finally there's a pull by earth, the weight, M times G. 10 times 9.8, 98 newtons. That force acts in a direction that is at an angle of 90 degrees with respect to the positive x-axis, with respect to the direction of motion, in other words. We will first note that the force in question, the total force acting on our object, is the vector F, the sum of the 4 different vectors, P vector, C vector, F vector, W weight vector. Now, I point out to you that the y component of the total force F is a sum of the separate y components, P sub y plus C sub y plus F sub y plus W sub y. Now, our block is moving only along the x-axis. It's not accelerating vertically in the y direction, positive y or negative y. Therefore, the y component of the net force on our object is 0. And so we complete this equation by substitution. P sub y is the p vector itself, magnitude of 60, times the sine of 25 degrees. The y component of C, the contact force vector, well, the C vector lies 100% along the positive y-axis, so its y component is whatever C is. So we just place a C there. Remove the subscript y. F sub y is the y component of the frictional force, which acts 100% in the negative x direction. No part of it points along the y-axis, or in the y direction, or the vertical direction. So F sub y is 0. And then the y component of the weight vector. Well, the weight vector points entirely along the negative y-axis. No part of it points along the x direction. The full value of W is the magnitude of the y component, but it points in a negative direction, so the y component of the W vector is negative 98 newtons. This third equation allows us to calculate the contact force. We obtain 72.64 newtons. We need the contact force in order to determine the frictional force using this equation, mu times C. 0.01 or 0.10 times the contact force gives us the magnitude of the frictional force. Now we know something about all 4 forces. Let's calculate the work done by each one of those 4 forces. The equation we will use is the most important equation in this chapter dealing with work, among other things. It's force times distance cosine, force times distance cosine. And so we have 4 such force, distance, cosine terms to add together. One for the pull force, one for the contact force, one for the frictional force, and one for the weight force. Let's go back to the pull force. Magnitude of 60, that's your force. Distance 6, cos 25. Contact force. Magnitude of the contact force times the distance times cos of 90. By the way, cos of 90 is 0. You should memorize that. Then your frictional force is the magnitude of F, the force value times distance, times cos of 180 degrees. You see that vector points to the left. The direction of motion is to the right, so the angle between the force direction and the displacement direction, 180 degrees. And then finally, the work done by the pull by earth, the work done by weight, is the weight vector magnitude 98, that's the force, times the distance 6, force distance cosine. 90 degrees is the angle the weight vector makes with respect to the direction of motion. Add all four terms, final answer 282.7 joules. That concludes this work calculation example.